Can you see my screen?
Yes, we can. Cloud networking with Terraform. Now with more bacon. And there's a
Right.
unicorn. Is that a gnome? That's
I don't know where that came from. I just searched unicorn bacon, and that's what came up. And I promised you there would be unicorns and bacon, and I'm just making good on my promises, you know?
that is beautiful.
So yeah, I'm going to talk about cloud networking with Terraform. You can badger me with whatever questions you might have. Just by way of how you could, get in touch with me. My Twitter handle is Ned1313. I have a website, nedinthecloud.com. So it's pretty easy to find me. If you're interested in any of the scripts that I showed during this demo, they're all available on my GitHub. I've got a repo up there called Terraform VDC demo. You can go there and, there's even a setup script to provision some of the things that you would need to get started. But first, let's kind of jump into conceptually what Terraform does and what it's a member of. So Terraform takes a declarative approach to deploying infrastructure as opposed to imperative. And if you're not familiar with that terminology, I will put it in terms of making a fluffernutter, which is a delicious sandwich that I plan to eat later. So in the imperative world, you are telling the exact steps to make a fluffernutter. So you would get the ingredients, you would put the ingredients on the bread, and then you would put the bread together. So it sort of spells out everything in detail. The declarative approach is more, let me tell you what I want, and then you go do it. It's sort of Picard saying, make it so. So in this case, for the fluffernutter, I'm kind of using semi-Terraform syntax. So I know that broadly, fluffernutter is a food. That could be argued, but we're going to go with it's a food, and it's of a type sandwich. And then I'm giving it a name of fluffernutter and telling it that the ingredients are peanut butter and marshmallow fluff, and that's it. That's all I need to tell whatever engine is taking this configuration. Then it has the understanding of how to build a sandwich. And maybe it's making some assumptions for me. So it knows that I like white bread, or it knows that the preference is for chunky peanut butter instead of smooth. So, depending on what the presets are, it might already know that stuff, or you could be more explicit in your declarative. But at the end, you get a tasty sandwich. Why do we like declarative? Declarative is a way to abstractly say what you want. And one of the things about declarative is it tends to be idempotent. That's a fancy word, which means if I run the same configuration multiple times, if the reality isn't any different than the configuration, then it's not going to change anything. So if I order up that fluffernutter and you give it to me, and then I run it again, you look at me and you go, well, you already have one. I'm not giving you another. Whereas if you run an imperative script, you'd have to put logic in there saying, check to see if he has one already. If so, don't create the sandwich. So it's kind of that logic, and internal logic is sort of baked in. HashiCorp Terraform is an infrastructure automation tool. It's declarative, it's idempotent, it's multi-provider. So what that means is Terraform makes use of providers to go out and get things done for you. So some examples that you'll see in this presentation are AWS and Azure. Both have providers within Terraform that allow you to go and provision infrastructure, especially networking, in their environments. But there's also providers for NSX. There's a provider for OpenStack. There's a provider for Kubernetes. So when you're building up configurations, the fact that you can do all of these in one tool is kind of nice. It's also fully open source, so you can go look at the code. You could contribute to it if you happen to know how to program in Go. I'm learning how to program in Go because there's some things that I think could be improved. But the documentation is open source too. So if something's missing and you feel like it needs to change, you can go and edit the markdown and submit a pull request. And they also take the approach with Terraform that it's a very focused purpose tool. So it's not a configuration management tool like Puppet. It's not a log management tool. It's not any number of other tools. It plays nice with all of those tools, but it really takes that sort of Linux mindset of build a tool that does one kind of focused thing and let it do that thing. In terms of structure for Terraform, what are its inputs? What are its outputs? So Terraform has configuration files that it ingests to output resources and other things, and those configuration files are made up of variables. So you can think of those as parameters that you're submitting. And then the providers that I talked about. And so each provider has a number of what they call data sources. So that's information you can pull down from the provider. So a good example, if anybody's familiar with AWS, you know they have networking availability zones. If you want to provision things in those availability zones, you first need to know which ones you have available to you. So you could pull that down as a data source. On the flip side, when you want to provision resources, you say, here's a resource that I want to provision, like a VPC, and then that hits the provider to actually provision the resource. So all that stuff gets munged together and submitted to Terraform. And then on the other side, it outputs a few things. So the first is the actual resources that you wanted to create. So if you wanted to create a VPC in AWS, it would create one for you. It would log the fact that it did that in its state file. So the state file is how Terraform keeps track of what the real world state is versus the configuration. So when you update the configuration, it takes a look at the state to determine if any changes are required to the real world. And it also has a series of outputs that it drops out to you. And those can either be something that you need on screen to take the next step in a manual process, or you could have something else on the output side ingesting that for the next stage of whatever your pipeline is for deployment. So last slide before we get to a demo, I swear. So the workflow for Terraform has 4 basic steps to it. This is the Mambo that you do with Terraform. The first is to initialize Terraform, and what that does is the various providers have their own executables to do work. So Terraform looks and sees what providers you're using and pulls those executables down. It also pulls down any modules you're using, and I'll talk about modules in a moment. And it also initializes the backend where you're going to put your state file. By default, it stores state locally, but you can store your state file in a remote repository. Once you've initialized everything, you run Terraform plan, and that actually looks at the target environment, looks at what's in the state file, and looks at your configuration and says, okay, what's the delta here? If there is a delta, what changes do I need to make reality look like what's in your config file? And then you can put that into an plan file, which that plan file is then used by running Terraform apply and feeding it the plan file, and it'll make the changes that it told you it's going to make when you ran plan. If for some reason you're done with an environment, it's a throwaway kind of thing. The last command that you could run is Terraform destroy, and that will literally get rid of all of the resources that Terraform created. So that's used with caution, I would say, and be careful about who has access to run that sort of command. But we're going to run through all of these in a moment. So I'm going to do, for first demo, we're going to stand up a simple AWS VPC. For those who aren't familiar with AWS, VPC is their virtual networking construct. They call it the virtual private cloud, or VPC. And within the VPC, you have things like an internet gateway, one or more subnets. Subnets live in availability zones. And then you have a route table that tells the subnets how to direct their traffic around the VPC or out the internet gateway. So let's jump over to Visual Studio Code, my favorite.
So quick question before you get into this demo, Ned.
Okay.
Now, you had that network diagram there you showed in Amazon.
Yeah.
You say in your experience, who are the folks that typically build this? Are these networking people that would actually leverage Terraform and stand this up? Is it more of an ops team with a broader set of skills and there is no like networking person or server person? It's just like cloud ops? What do you see?
I've seen both. So I've seen ones where the network admins are getting very involved in the cloud infrastructure because it's going to tie back to their on-premises infrastructure. And so they need to know what people are going to be deploying. So I've seen that, and that's what I would hope if you're a network admin, that you are getting involved. Otherwise, you're going to reap the whirlwind later when they do something incredibly wrong. Or I've just seen, cloud ops people who have enough networking background that they're comfortable deploying this stuff. So it's kind of it's a mixture.
And can this be set up so that a network person could essentially create a package or like a script to give to a server team or other developers and say, when you're standing up something in VPC, make sure you include this in your process? Or does it have to be handed off to a networking person?
No, you can do exactly that. So that would be sort of a use case for modules, which I was going to show those in one of the demos as well.
Okay.
So in this first demo, I just have one file. It's the Terraform configuration file. I'm going to drop up to the top. We got a number of different variables here that the provider and the configuration require. So variables, like I said, are kind of like parameters. The actual values for these, you can either have a default value, like I have here for the network address space for the VPC, or you can pass those variables in the command using a file that has the values in it, or by actually doing -var and giving the key and the value for that variable. And then for the providers, you just specify a provider. Each provider has different requirements for what is required. So the AWS provider wants your access and secret key, and then a region to place it in. It is possible to put your access and secret key in environment variables, and it'll read out of that instead of providing it directly. And then I'm going to pull data from the provider by saying I want type data, AWS availability zones, and if you control click, because I have the Terraform provider installed, this will take you to the actual data source, which will tell you exactly how to use it and what arguments exist within it.
Oh, is that a fancy feature of code?
That's a feature of code, and I think a lot of other IDEs that have a Terraform plugin will do that as well. Once you properly type the name of the data source, it then becomes clickable, so you can look it up easily. Because I certainly don't have everything memorized, and I wouldn't expect anybody else to.
You kind of went over it quick on the keys, but going back to your code there, you mentioned the keys could be stored in variables. That's one of those things that you really want to be careful with those keys, I assume.
Yeah, those keys could be fairly important, because certainly they can do things within AWS. So usually you'll create an IAM user with roles specific for network deployment, and then generate keys for that user. So you don't have one admin user that you've got the keys for, and if someone steals your keys, they can do all kinds of crazy things.
Yeah.
And then when we get down to resources, the way that the resources work is you say this is a resource, what type of resource it is, and then give that a name within the configuration that you can reference back in other resources. So I'm creating the VPC first, and then I'm creating the internet gateway after that. And then I'm creating the 2 public subnets and the route table. So there's a bunch of stuff in here, and this sort of syntax here where it's $ curly braces, that's Terraform's special way of interpreting special values. So in this case, I'm referring back to a subnet I already created in the configuration. So it's a type subnet, the name of it was subnet 1, and I'm just getting the ID attribute out of that resource object to feed into this resource to make that association. So if we want to go through the actual commands to get this party started, we'll start with Terraform. Oh, I should probably be in the right folder, huh? That might be helpful. Okay, there we go. So run the initialization, and you can see it saw that I'm using the AWS provider. So it's going and downloading that plugin. Once it's downloaded.
And again, that plugin is doing all this magic for you. It's effectively an abstraction layer that makes it easier for you to interact with AWS.
Exactly, and there's official providers and then unofficial providers, let's say, but all the providers are maintained by teams outside of HashiCorp for the most part. HashiCorp contributes to the AWS and Azure ones and a few others, but then there's a whole other catalog of providers that were just created by the vendor for the most part. Just realizing that a lot of people are using this tool, it would be good if I had this tool in the tool belt for people to use. So they write their own provider, and as long as they follow the all the documentation and it interfaces nicely with Terraform, it works. So yeah, if I go ahead and run plan, I have all my variables stored in a Terraform vars file right here, which I won't open because it has my access and secret key in it. But it's really just the name of the variable equals whatever the value is. So I ran plan, it looked up in AWS and said, you don't have any of these resources right now. So that green plus sign that's next to all of these things says, I'm gonna create all these resources for you. So if everything looks good to me, I just go and run Terraform apply. And so it's going to take that plan file and apply what I asked it to do to AWS. And fortunately, AWS is pretty fast, so I can actually do this in real time. And I did have an output there where I'm just retrieving the VPC ID. So if I jump over to...
You say apply it to AWS, and specifically, it's now making calls to AWS against the API and doing things. It is making what was in that plan.
Yeah, it made all the things that are in that plan. If I go to my EC, well, I don't want EC2, I want the VPC console. If I go to the VPC management console and go into my VPCs, there we go. This one-demo VPC is what it just created.
Mm-hmm.
And if I click on that, it'll show me it's got the appropriate CIDR that I specified. I can go and look in my subnets, and there will now be, well, it's hard to tell which one, but it's this first one up here. These two are the subnets that are associated with that VPC. It's just kind of the way that it does it. And it created the route table and the internet gateway. So this network is now ready to provide dial tone functionality for the next environment or the next set of users.
Huh. So the complexity of the AWS environment I could create is essentially unlimited. It sounds like I could build whatever I want and interconnect them as long as I've got the hooks in Terraform. I could build that script, run that plan, and stand it up.
Right, and this was a super basic one because I actually wanted to be, created within a regular amount of time. But if you have certain security requirements, you want to add ACLs to subnets or to the internet gateway, if you want to create security groups to restrict what traffic can flow between different VM types, you can have that all kind of pre-programmed into here. So you can really create sort of a module that you can hand off to the app team and say, okay, when you're standing up the environment, you need to run this first. It'll create all the networking, and then you can create your VMs within it.
Can you also do other things like set it up across multiple regions or availability zones for load balancing or failover, that kind of thing?
Yeah, absolutely. So when I created the provider, let me scroll real quick. I specified what region that provider is for, but you can actually instantiate multiple AWS providers, and you just give each one its own name as well as a region, and then you would have one called like AWS East 1, and you can refer to that when you're invoking the resource creation.
Okay.
Even more fun than that, let me get back to, where are they? So best practices in design, just a few quick things. If you're going to be writing these configurations, it's best to put them in source control, SCM, source control management, mostly because you want to be able to roll back to previous versions, and that's something you can do pretty easily with Terraform. Is when you update the configuration, if you did something wrong, you can roll back to the previous configuration. Using remote state is generally recommended, and that's because if you're just doing it by yourself on your desktop and you're never going to work with anybody else or on any other computer, local state is fine. But if you're going to be doing any sort of teamwork with other people, you're going to want to put that state somewhere that everybody has access to it, because that's how Terraform figures out what the real world looks like versus the configuration file.
Single source of truth would be that remote state then?
Yeah, that would be your single source of truth for the environment. There's also a concept of workspaces, and workspaces are like logical partitions of Terraform. So each one has its own state file. So if you wanted to use the same configuration to create dev and QA and production, etc., you could use the same configuration file and even the same directories. It would create a different remote state file for each environment. Modules, I mentioned them a few times. So modules are a way to create something for common components, like maybe a VPC. And so modules are basically like their own mini Terraform configuration that have some set inputs and some set outputs. And then other Terraform configurations can invoke that module, pass it the inputs, and then ingest the outputs for additional configuration. So AWS and Azure and a couple other providers publish official modules for really common configurations like the VPC. So that's one way to do it, or you can just create your own. And then the last thing, to get back to something that we talked about a little bit before, was you could have the networking team building the networking layer and then have the application team deploying on top of that. And the best recommendation I have is kind of separate things out by workload. So if you have multiple application teams deploying different things, each of them would have their own Terraform configuration for what they're deploying. And then the underlying network to support these workloads would be its own configuration by itself.
So one question that's come in, Ned.
Sure.
Now we're looking at cloud networking. That's a use case here that we talked about.
Yes.
What about Terraform for networking that's not cloud? Something inside my data center.
Sure. So, like I said, there are a whole bunch of providers out there. One provider that jumps out in my mind is probably the VMware provider, includes NSX support. So if you have NSX in your environment, you could use Terraform to do the configuration and management of some of the NSX components. So that would be one. Another could be Hewlett-Packard Enterprise. Their OneView software has a Terraform provider, and that can be used to configure all of the OneView controlled components.
Yeah, that makes sense, because OneView was, the last time I heard about its architecture, it was designed with the ability to go out. You talk to OneView, OneView talks to all the stuff underneath. So if Terraform is talking to OneView and offers that provider, then it would end up being the middleman that pushes all the network config information down into the network. I can see that.
Absolutely. And so I would say anything that's like SDN, I know it's kind of an abused term, but if something has a unified control plane like NSX, like OneView, with OpenStack's, what's their network provider, Neutron?
Yes.
Neutron, yeah.
If it has something like that, then Terraform will get along just fine, because it needs something it can go talk to say, all right, this is the configuration, go make it happen. If you're running in a distributed environment that doesn't have that central control plane, then it's a little more difficult for Terraform to do that. And I would say for like networking configuration, that might be a better suited job for something that's in the configuration management space, like Puppet or Ansible or SaltStack.
Yeah, because Terraform here really cares about that state. It wants to go to that single source of truth, that one place where everything, all your configuration state and so on is living.
Right.
And again, not be hitting config against a whole bunch of different devices. That's not how it thinks, the way you're describing it here.
Yeah, it's invoking the provider, and the provider talks to some sort of API endpoint to make things happen. If that API endpoint doesn't really exist, then that can make things a little more difficult.
Is there a sort of verification component outside of going into my AWS console and saying, yes, this VDC environment was created?
Well, I mean, if you trust your configuration, if you go ahead and run plan again, it'll tell you that nothing is different, and so nothing has to be changed. So if you were you had an environment and you're worried that somebody went in and tweaked things outside of Terraform, then by running Terraform again, it'll tell you if something's out of whack with the environment that it manages.
Okay, well, that's neat.
Another question that's popped up here, Ned. I know you. I think you have more to go through, right? So I don't want to.
I do, but you know what? Like, okay. I'd rather answer questions than try to rush through a demo.
Well, here's another one that's popped up. I don't know how this fits or not, but here's the question: what about using Terraform for Office 365 domain migrations?
Oh my goodness. Well, Terraform certainly has an Azure provider, and part of that Azure provider is DNS. So if you're using Azure DNS, you could definitely use it for that. But if you're talking about within actual Office 365, I happen to know a little bit about that. The domain migration process for that is specifically you have to completely remove the domain from one tenant before you move it to another. And that is not generally something that I would do with Terraform. So you could certainly control the DNS side, the public DNS provider side of things, because Microsoft wants you to add a text record to your public DNS to verify that you own the domain. But I don't think there's a provider specifically for the Office 365 tenant interface. But hey, if you know Golang, I guess you could go write one.
All right, Ned, I think we're out of questions for now. If you want to keep moving along, you got about 20
Yeah,
more
sure.
minutes.
Oh, wow. Okay, cool. So the second demo that I wanted to show is using the module and using remote state. So we're going to do that. So I'm going to pull down AWS's official VPC module and also merge that with the Terraform configuration. And then I'm going to be storing the remote state in an S3 bucket. So if anybody's not familiar with AWS, S3 is their simple storage service. It's blob or object-based storage. So it's going to drop the remote state file there. And then it's going to use DynamoDB to lock the state file. And basically what that's saying is either while I'm running plan or while I'm running apply, I don't want anybody else messing with the state file or the configuration. So I'm going to put a lock in that table, and anything else that's trying to manipulate remote state has to check that table first, and then we'll say, oh, somebody else is doing work. I'm not going to change anything. So you don't have like colliding changes in a larger environment. So jump over here, close these guys out and open up demo 2. I also broke out the files a little bit. So Terraform looks at all of the files that are in a folder and not just one. So it'll take all of these different .tf files and merge them together into a single configuration. It's pretty common to split out the various components into their own files. One, it makes them pluggable. So I can, if I have a solid backend file, I can copy and paste that into a different folder and have, you know, the same basic backend. And same thing with variables and resources. So this is the backend. This is how I'm telling it to talk to S3 for its remote state. So I'm giving it the key, and the key is actually the name of the remote state that I'm going to use. And I'm also specifying what region, what the bucket name is, and what the DynamoDB table is. So get into that. Variables are very similar to the variables that were in the previous example. For resources, I've got my provider and data again, so that's exactly the same as the previous. But for networking, instead of having the subnets and the routing tables and all that, I am invoking the module keyword, telling it that the name of the module is VPC, and I'm sourcing it from this path, which is actually Terraform understands that this is an official module, so it's going up to the catalog and finding the module at this path. And then I'm passing it all the arguments that that module wants, some of which are required and some of which are optional to create my new environment.
Meaning you have to, you've got CIDR, availability zone, private subnets, public subnet. You have to put all of those in and feed that in, or what, it's going to error out, or will it make some assumptions, or?
Well, some of these are optional and some of them are required. So you'd have to hit the documentation to see exactly what's required.
Yep.
It does need, at the very least, the CIDR and the private and public subnets. I think everything else in there is optional. So if you don't tell it which availability zones, it'll just grab the first 2 and drop your subnets in those.
Okay.
In terms of running this, so the first thing I need to do, as before, is to initialize the configuration. So I'll run that. So in addition to grabbing the AWS provider, it actually went and looked for the module.vpc, and it found, let me scroll up a little bit, sorry. It found version 1.46 of that module in registry.terraform.io. So this is the website that has all of the official modules. And so it pulled down that module locally so it can use it. And then it configured its backend to use S3, which is what we wanted, and it downloaded the plugin for AWS. So it did a whole bunch of things as part of that initialization. And then the rest of it is pretty standard. So let me run plan. It should, there we go. Yeah. So it's basically creating 9 new resources, and then I can run apply, and it'll go out and generate all of those items. If we go to the AWS console, got that somewhere, and go into S3, this is my bucket that's got the demo stuff. And there's the two demo state. So this is the state file that it's working with right now to write out the state remotely. And it's done. Hooray. So we have another VPC. Super exciting.
So now contrast what Terraform does here to Ansible. I mean, would you actually use Terraform instead of Ansible, or do they each have a home?
I think they each have a home. Generally, when I've used Ansible in the past, it's been for more on-premises stuff. Applying configurations to switches or to Linux servers, those types of things. It's nice because it's agentless, and it does have some of the same idempotent features. I think Terraform does infrastructure deployment really well, like automating your infrastructure deployments, but it doesn't do configuration management. It doesn't claim to. Ansible does configuration management really well, and so that would be sort of, I would kind of put them together even to the point where I would deploy, I've done this before, deploy everything via Terraform and then configure like the EC2 instances in such a way that they're ready to be connected to from an Ansible deployment. So third demo, just to kind of give an idea of this cross-cloud ability. So I have a configuration that's going to use both an AWS VPC module and an Azure VNet module as the network configuration. It's going to store that in remote state. And then as a follow-up to that, I have a second configuration called VPN configuration. That's going to read information from the remote state and deploy a remote access server in the VPC and a virtual network gateway in the Azure VNet, and then create a VPN connection between the two. Unfortunately, Azure likes to use IKE v2 for their IPsec tunnel, and AWS only supports IKE v1.
Really?
So, yep.
Wow.
So you can't use the native virtual private gateway in AWS to connect it directly to the virtual network gateway in Azure. And because neither of them is willing to back down or add functionality for the other one, you have to do some sort of workaround like deploying a remote access server in your VPC to create that VPN connection, or you could use any of like the third-party virtualized network appliances to do it. But yeah, I found that out when I was building this.
A little bit of shame on AWS because it's not like IKE v2 is new and there's good reasons to use it. So anyway.
Yeah, I wish that the two cloud providers would not act like children sometimes and just like, okay, can't we all just get along? Like, I have to work in both. Please try to make my life easier. But no. So for that demo, how am I doing on time? Okay, I'm good on time. I already deployed it once because the virtual network gateway takes about 20 minutes to deploy, and I didn't think people wanted to sit and watch a screen scroll for 20 minutes. But in terms of configuration, it's very similar to the previous one, except that I have two separate folders here. I've got a network and a VPN. So the network configuration deploys out the VNet in Azure and the VPC in AWS and stops there. So for the resources, I have both providers in here, AWS and Azure. And then I invoke the VPC module to create the VPC. And I invoke the VNet module to create the VNet. So that makes life, a little bit easier because I'm just using those base configurations.
So, okay, and between those two modules, though, I mean, are there different directives underneath them, or do you actually just get to say, different modules, but here's all the same information, and it builds, what needs to be built respectively in each environment?
Each of the modules takes different settings because, of course, VPC and VNet have different concepts in them because, of course, they do. They get back to that children thing. So Azure doesn't separate their subnets by availability zone. It just has subnets, and it doesn't necessarily differentiate between public and private subnets unless you get into manipulating the user-defined routing. Whereas AWS is very much, these are your public, these are your private, and they have to be placed in availability zone. So I have to give it all that additional information up front.
So does that mean it's sort of incumbent on you to know the different constructs and terminologies in these different clouds to get it into Terraform, but then once it's there, you
Yeah.
kind of have a model?
So it's interesting. One of the things that I've talked to people about is there are management tools out there that claim to be able to write one config and deploy to any cloud,
Yeah.
which means that they have to abstract away to the lowest common denominator of whatever cloud exists that they're going to support, which means that you might lose some functionality in the process. Terraform takes the different approach, which is it doesn't abstract away the actual fiddly bits of the cloud. It just gives you a tool that you can learn really well and be able to deploy to any of these different environments, but you still have to have an understanding of what makes up an AWS environment or an Azure environment.
Okay, so they're not hiding it from you.
Right, and that's, I mean, in my experience, that's what I prefer because you already have so many layers of abstraction. Adding one more, it makes it almost impossible to troubleshoot, and also you're losing any like key functionality that you might choose one cloud over another for.
Okay, yeah, that makes sense.
Now, I know you haven't actually run this yet, but one more question here that's popped up.
Yeah.
Can Terraform call an Ansible playbook? I'm assuming what that means is could it tell Ansible to go do a thing? Or maybe it could mean, I guess, could it actually read a playbook and pull data out of it?
Yes and yes. So it can invoke a playbook, not directly from the provider, but what I've done before is when I'm spinning up EC2 instances, it can run, you can either drop it in the user data if you know EC2 really well, or there's a thing called it's called provisioner, a remote exec provisioner. When you create an EC2 instance or an Azure VM, it will connect to that VM via SSH or WinRM and run whatever scripts you want it to. And so you could really just use that remote exec to invoke an Ansible playbook on whatever instances you're spinning up. Good?
Yeah, I think we're good. Let's get the demo in.
So this workspace, I've already created a workspace called V1. So I'm going to create a new one called V2. So the workspace is what separates the remote states. So I can have multiple versions of the same configuration separated using workspaces. So you do have to initialize before you create the workspaces because it needs to know where it's storing that remote state. I've already initialized it once, so it probably won't do anything, but that would be the process for initializing it. And then to create a workspace, you just say Terraform workspace new and give that workspace a name. It'll create that workspace and then automatically switch you to that workspace. And then we can just run the standard, Terraform plan apply. So this will create the VPC and the VNet. And that creates a lot more resources than the previous one. So 14 new resources. And then I would run apply to create them. So while that's running, the second configuration, which is called the VPN configuration, for that, if we look in resources and scroll down a little bit, so I'm using a module that I wrote myself. So this is a module to deploy the Azure Virtual Network Gateway. The reason I did that is because the Virtual Network Gateway doesn't get a public IP address until it's fully provisioned, and the AWS side needs to know what that public IP address is going to be. So I invoke a module that creates that Virtual Network Gateway. It goes through the whole creation process, spits out a public IP as part of its output, and then I can ingest that information in my main configuration to spin up the RAS server and hand it that public IP.
Because that's a dynamic bit of information. You don't know what that public IP is going to be, so you
Right.
gotta wait till it's built, then pull it, then act upon it to build the tunnel.
Exactly, and that's sort of some of the fiddly bits that you get into with Terraform once you start doing some more advanced configuration. The other thing here is I'm actually pulling data from the network configuration by invoking data.terraform remote state. And so that knows to go out to where I have that network remote state stored, and I want to retrieve the VNet CIDR to hand that off to this template file. And I think, where do I actually, oh, here's the remote state. So here's where I tell it, this is a remote state called network. Where does it exist? And how to retrieve it. So I have to give it AWS keys to access that bucket to get the remote state out. So if you were in a larger distributed team that you have an application team that just needed to know information about the network deployment, they could pull information about your network state without having any access to modify that state. Okay, so that's deployed. Do I want to go? I only have 5 minutes left. Yeah, I'm not going to actually run the virtual network gateway deployment because, like I said, that takes 20 minutes. But it will create it, and it'll also create an EC2 instance and feed it a user data script that actually installs the remote access components and configures them to create that VPN connection back to Azure.
So when the tunnel is up then between AWS and Azure, as shown on the diagram here, if you've done all that, is there also like routing components that need to be installed in places? Like does AWS need to know, hey, go through this VPN tunnel to get to whatever the subnet is on the Azure side and vice versa?
Yeah, exactly. So on the Azure side, you create an object called a local network gateway, which is confusing because it's not local to Azure, it's local to your on-premises. But the local network gateway has IP addresses associated with it. So the Azure VNet just knows when traffic is destined for the local network, for that local network, send it out the virtual network gateway. So that's the only object you need to create for Azure. For the AWS VPC, you actually have to put routing rules in the route table to say, for this new subnet, send the traffic across either this VPN connection or to this RRAS server. So the RRAS server is listening for traffic destined for that remote network.
Another question that came in from the audience, Ned. It's not Terraform specific, but the question is, can you give an example of a tool that is general and creates layers of abstraction for creating infrastructure for both AWS and Azure?
Oh, geez, what is the one that everybody likes? There is one, and of course, it's completely escaping my mind right now. I know there's a couple out there in the market that are claiming to do this sort of thing. I think to a certain degree, VMware's their automation suite, VRA, tries to do some of this, but I don't think it abstracts things so totally. Morpheus is another offering that does something similar. And then there's one that they produce the State of the Cloud report every year. I'm trying to remember the name, but they also kind of do that as well. So a lot of these started out as just like basic automation suites. And HP has one called OneSphere. I probably wouldn't go near that, but you know, you take your life in your hands when you choose HP software. Don't get me wrong. I like their hardware, but sometimes their software leaves a little bit to be desired. I hope I don't get fired for that.
And just to add on to that, Ned, most of the hyperconverged infrastructure providers have some kind of a flavor now where they'll manage your resources in the cloud. That's not exactly what you're asking for, person that asked that question, but it's becoming more and more common for your HCI infrastructure can now deal with stuff that's in AWS and Azure and in your private cloud as well.
RightScale, that's the name of it. So RightScale has a tool that'll do that. See, I knew it began with an R. I feel better now. So yeah, that's RightScale. I did have one more demo, but I think we're pretty much out of time. But if you wanted to run this demo on your own, it's pretty cool. It checks stuff into GitHub. GitHub gets pulled by Jenkins, and then Jenkins deploys your network configuration via Terraform and drops it in a remote state. So if you're in the automation space and you're looking to automate your network deployments, Jenkins has a Terraform plugin. If you're not familiar with Jenkins, it's a CI/CD, continuous integration, continuous deployment tool, and it has the ability to pull source control and see if changes have been committed, and then it can put that into a pipeline to deploy those changes out to your environment, or it can take that pipeline to a certain point and then send a notification saying, hey, there were changes. These are the changes that would be made. Do you want to execute on those changes or not?
And again, you said people could run this themselves, as in they can pull this from your GitHub repository?
Yeah, so I do have a fourth demo in here. It would require you to set up a Jenkins server, but it has the Jenkins file in here that describes the entire pipeline.
Yep.
So you can set up your own Jenkins server, which it sounds intimidating, but it's really not. If you go into Azure and you have some credits in Azure, they have a Jenkins VM in the Azure Marketplace, which is exactly what I did. I just deployed it from there, and it does pretty much everything right up to the click-through configuration. And if anybody has questions, feel free to hit me up on Twitter and ask, and I can kind of help you through getting that set up if you wanted to see that actually in action.
I've got a quick question for you, if you don't mind, Ned.
Sure. Yeah, go for it.
So we're hearing from folks like Juniper, Arista, and others who are putting essentially virtual routers into marketplaces like AWS and Azure, where you're supposed to use them as sort of the routing constructs. Have you worked with those with Terraform, or do you think you could?
I actually did a project using Citrix Netscaler that also used Terraform.
Okay.
And basically Terraform did the deployment of the virtual appliance, and then I had a predefined config file that needed to get uploaded to the Netscaler to just kind of lay down the base configuration, and so it would SSH through that remote exec provisioner and execute the basic configuration script. So yeah, you can absolutely do it.
Okay, great.
Well, Ned, parting thoughts, if people want to follow you, you said you got Pluralsight courses. If they want to get started with Terraform, yeah, here you go, this slide.
So if you want to,
this one.
if you want to know more, I hope you do. You can head to the Terraform documentation. It's pretty good. I think it could be better. If you want to make it better, do a pull request or log an issue in their GitHub. If you like Pluralsight and have a membership, I have 2 courses on there, Getting Started and Deep Dive for Terraform. So that's a way to get started. If you're a person who likes reading books, there is a book, Terraform Up and Running from O'Reilly, that is excellent. I didn't write it, but somebody very excellent did.
So, up and running books are usually pretty short, not short, but tight, focused on getting the environment up, not everything there is to know.
Right, it's not long and rambling. It's something that you can really sit down and lab your way through. If you want to check out, if you go on GitHub, Ned1313, you can look at the repository on there with all of the various demos that I ran through today. And if you have questions, just hit me up on Twitter. My DMs are like mostly open, so I think I have to approve them or something, but yeah, they're basically open. So hit me up or just mention me on a tweet, and I'll get back to you.